One of the main missions of the International Space Station is to provide us a way to learn what it's going to take for humans to live in space long term. And that covers everything from what the absence of gravity does to astronauts' bones and muscles, and also all the way down to more simple things like what it's like to drink a glass of water in orbit. The Dragon cargo ship that arrived at the station last week is carrying an experiment known as the Capillary Beverage, and that may change the way that astronauts drink in space. So this morning, we're going to learn more about it from the principal investigator of the experiment, Dr. Mike Weislogel, the vice president and senior scientist at the research firm IRPI, and a professor of mechanical engineering at Portland State University in Portland, Oregon. Mark,
Greetings.
thanks so much for joining us.
Yep.
So, astronauts have been drinking through straws all these years. I guess are there reasons to change that? Are there disadvantages to it?
Well, there are certainly reasons to do it. I mean, you can imagine flavored drinks being reconstituted from powders being an absolute nightmare with gravity gone. And it's a real challenge problem, and it's solved by having it done in a bag. It doesn't mean there aren't any hazards with bags. You could easily hiccup with your hand holding one of the bags, and you would squeeze the bag and send out a jet of liquid, or you could that kind of thing. There are still some hazards with it, but confined to the galley, it's probably okay. With a cup, the astronauts would have an experience kind of like Earth, and you'd be able to smell the aromas, and you'd be able to experience that kind of bonding phenomena that takes place when you're drinking a cup of coffee with friends during a break, and that can relieve some of the stresses that are up there.
So there's definitely, I guess, a psychological advantage to that experience, to making that
Yes.
connection.
Yes, there is. There could also be one, for instance, picture a long duration mission where you use reusable cups instead of thousands of disposable drink bags. You could expect maybe a significant savings in volume and mass also. But here, this is largely about fun, and that was the idea about it in the first place. And I can tell you more about that if you want to, but whatever.
Okay. Well, let's back up just a little bit. I know this builds on some earlier experiments that weren't, I guess, necessarily aimed at such a fun experiment, but in capillary flow. Can you just kind of go back and explain a little bit about that for us?
Okay, so we've been doing a lot of work in drop towers and low gravity aircraft and shuttle experiments and things over the years. And recently, I'd say over the last 8 years or so, we've had a slew of experiments that the astronauts have performed, as well as robotic experiments that all look at how liquids behave when the effects of gravity are small. So what we're doing is we're changing the shapes of containers and in such a manner that the liquid moves to the right locations passively, spontaneously. And it's driven by surface tension and wetting forces, but it's also crazy geometry. And we're developing the methods to do that so that you don't use pumps, you don't use centrifuge, you don't need gravity. The container determines its own bottom. And so where the liquid is when it's time to use it. We're trying to make plumbing in space mundane instead of this aggravating, scary actual process. It's a terrible thing to try to flush the toilet, for instance, and then where's the water? Or to drain the fuel tank, but where's the fuel? That kind of thing. To feed the mice with water, at least, excuse me. But where's the water? That kind of thing. So we want that to be passive. We want that to be mundane. We want those challenges to go away. And the coffee cup, for instance, or the beverage cup is an example of how we can do this in a day-to-day, living in space kind of way.
So that's just a very practical example of the research you've been doing, right?
I think so. What spawned it was this the Italian espresso machine, the IS Espresso that's going up, and the fact that there's these complex drinks that are up there, and then it just steamrolled from there. But
And I
a
know,
chance to get to space with something like this.
well, and I know astronaut Don Pettit created something that looked kind of similar back when he was on the space station in, I think, 2008. Is that, you worked with him on that, right? Did that spark
Right.
the idea here?
Right. So one day he complained about drinking liquids from a bag, and the feeling he felt associated with that. And so we emailed him, hey, you could do this and that, and he went over to he got some materials that were on space station and constructed this thing, and that demonstrated the phenomena and how you can replace the role of gravity with that of surface tension, wetting, and geometric shape of the container. And now the new one, though, is full-blown design. So now here we use the design models that we use for industrial design or commercial aerospace or NASA-related aerospace stuff, bring it all together in a cup. And the geometry is complicated, and but it can be 3D printed. And here we're going to dink around, having fun actually with astronauts during mealtime. But we also expect to get quality science from this to verify and validate the models that we use. So it's really got this two-pronged effort, to see what's going on here.
Well, I saw that the crew is actually going to demonstrate these cups today. So what exactly is the experiment? Is there data that they'll be collecting, or just seeing if it works?
Okay, I think they're unpacking things today. If they're actually experimenting, it's new. It's information to me if they're going to be using it today. But we're on 2-hour call, so we're on the task list to be run at any time. But this is an example of the cup. Okay, so this thing is 3D printed out of a transparent polymer, and it's been run through a series of tests to render it, safe to drink. It can be and we have go ahead for all 50 drinks on the space station. And right now we're touch temperature drinks, but once we demonstrate it's safe, then we can maybe pursue hot beverages like tea, coffee, things like this. What was I saying? Oh yeah, so this cup, okay, this is a demitasse. It's for a shot of espresso. Okay, there are 6 cups like this on the space station. This one is a small one. The other ones are a little larger, some with handles, some with different shapes. The astronaut will use a drink bag to fill the cup and then enjoy it in the galley, just drinking like this. So once a connection is made with the lip, the entire contents can be drained into the mouth, and it'll be pretty much like a drink experience. The nose will be centered over the opening, so you'll get a nice whiff of whatever it is. It'll feel somewhat like Earth. It'll be different. You'll adapt, but it'll have much that same feeling. The thing is, only 20% of the activities, though, are for fun in the galley. 80% of the effort is actually going to be out in the laboratory with cameras, orthogonal views, HD visualization, downlink video, and we expect to get profile views of good magnified profile views of what the surface shape looks like, the drain rates, the flow rates, the stability, everything about it. And the point of that is to provide what we call validation and verification of all the models that we use. They're complex drinks. The wetting isn't perfect. All of these things that all will actually really improve our knowledge for designing systems for wastewater processing on space station. For drinks, perhaps, how you process urine and brines and things downstream. Condensates, water supply, this kind of stuff. So it's actually going to be very valuable data to us, and we actually want to turn around and use it for advanced systems design. That's our intention.
Well, that's a great way to test it. It sounds fascinating. So we can't wait to see the crew hopefully using them pretty soon, and definitely the results as they start to come in. Thank you so much for joining us, Mark. We really appreciate it. And again, that was Mark Weislogel, who's the Vice President and Senior Scientist at IRPI Research Firm. Thanks again.
You're welcome.